So we're now going to look at air-gas mixtures. Air-water mixtures, not air-gas mixtures, air-water mixture. So air-water mixture, which is in form of gases. So this is a type of gas mixture. So with the air-gas mixture, we do have different scenarios where we have to come across such conditions, and then we have to work out the properties that are in those conditions or in that mixture. So first of all, I would like us to know some terms. So first of all, the due temperature. So due temperature is the temperature at which a liquid condenses. So that's temperature at which a liquid condenses. At that temperature, it is at a certain pressure, which is known as the saturation pressure. Another thing we're going to look at is the relative humidity. So the relative humidity is denoted by this sign. So the relative humidity is equal to the pressure of the vapor over the saturation pressure. Please bear in mind that these are used in air-water mixtures. So the pressure of the vapor is the pressure of the water vapor over the saturation pressure of the water at that given temperature. So this is the given pressure, then this is the saturation pressure at that given temperature. Okay? Then the humidity, we're going to have the humidity ratio. So the humidity ratio is denoted by this sign, omega, which is equal to the mass of the water, which is the water vapor, over the mass of the air. And the units are kg water per kg air. So this is the humidity ratio. And then we're going to have the change in humidity ratio is equal to the change in amount of water in the gas mixture. So this is equal to the negative change or the negative amount of water that condenses, which is in kg water per kg air. This means that if we want to find the mass of a condensate, if we do have a mixture of air and water vapor, then the temperature changes or the pressure changes, then we have a change in amount of water. If we want to find that change in the amount of water, all we do is we get this change in humidity ratio and multiply it by the mass of the air. This is because the air will not condense and the mass will remain the same. Therefore, we use the mass of air, and also looking at these units, we have the mass of air on the bottom. So if we multiply the mass of air, which means it's kg per water, kg water over kg air times kg air, which means the kg air will cancel out and it will only remain with kg water. This can also be used in for other gases, for where there's a liquid that's condensing. For example, maybe if we had nitrogen and air, and nitrogen was condensing in air. We can also use the same formula, but mainly it's used for water, and in this situation or using it for air water mixture, gas mixture. Okay, so another way for water, just for water, this is specifically for water, the humidity ratio is equal to 0.622 times the relative humidity times the saturation pressure at that given temperature over the total pressure minus the same value here Yes. So please bear in mind the saturation pressure is different from the total pressure. The vapor pressure is also different from the total pressure. But the vapor pressure and the air pressure added together give us a total pressure. And then the saturation pressure is just the pressure at which the liquid will start condensing. This water vapor will start condensing. And then we also have another formula here, which is the relative humidity times the saturation pressure is equal to the humidity ratio times the total pressure over the humidity ratio plus 0.622. Keeping in mind that the 0.622 is derived from the molar mass of water over the molar mass of air. So now, with these new definitions that we have learned, we're going to see how we can use them in the psychometric chart. This psychrometric chart is a chart which is used to analyze a gas and air water gas mixture. So we're now going to have a look at the chart and see how we can use it.